Okay, so are you able to see my screen?
Yeah.
Yeah,
I am.
everybody see the screen. Perfect.
Monica, I think we will be able to share the link after the session. It's up to the Fab Foundation organization, but I think we'll be able to do it. Let's try to do it at least. Yeah.
Okay.
Let's go.
So let's start. So welcome everybody. Let's present us. So we're gonna present you our open source incubator that promotes fermented food and collaboration with natural processes. But first we're gonna present ourselves. So we are both from Belgium, but we are now settled in Barcelona. I have a background in architecture and I did 1 year internship at VAR Fab Lab Amsterdam. I divided my time there between the main Fab Lab and the open Wetlab. I learned how to use digital fabrication techniques, but also how to work with living things. And I ran several experiences with mycelium, kombucha, and pigmented bacteria. Then the year after I moved to Barcelona, I joined the Fab City Hub of Barcelona, which is working to understand, learn, and experiment with projects aiming for urban self-sufficiency within food, energy, and materials. My goal there was to build a biolab kitchen as a strategy for urban resilience. Then Antoine, go on, please.
Yeah, and so my name is Antoine Jonard, also from Belgium, living in Barcelona, even though I'm visiting my family in Belgium now. So I'm in my tiny room here in Nivelles in Belgium. I have a background in graphic design and web development. And I'm also an alumnus from the Fab Academy 2020, where Fab Academy, as you may know if you're part of the Fab Lab network, is a courses where you learn to make almost everything according to the baseline, designing electronics, using all the machines available in Fab Labs around the world. After that, I gave a hand to the Smart Citizen project here in Barcelona, which is a project that make and develop tools for citizen action in environmental monitoring and methodologies for community engagement and co-creation. Yeah. Yes. And just like before going on, I also would like to precise that this was intended to be a hands-on workshop in Montreal. But according to the circumstances, we had to do like this remote presentation that will be more lecture than a workshop, but please interrupt us if you have any question or if you would like to add a point live into it, please bring it to the table if you want to.
Yeah, sure.
Yeah.
So our interests and common vision. So we both believe that in the age of Anthropocene and climate crisis, there is a need for innovation, but that's most of the innovation must be like underneath from the missing link between nature and humanity, which is observing and understanding natural system for more synergies, which is reconsidering our place in a world that we cohabit with other species and that we have something to learn from intelligences other than our own. And that is also advocating relationship with non-human beings based on gratitude.
And now, what's an incubator? Because like we have a lot of people that like what we do, supporting us without knowing exactly what it is. And now today we'll try to explain it. What's an incubator, what to do with it, and why are we making and spending on time making it? So as Maud said, with the desire to encourage fermented food, collaboration with natural processes, and food waste recycling, we are designing and developing an incubator. An incubator is a device, that wooden box there that you can see on the image, a device that maintains the necessary parameters, such as temperature and humidity, for an environment suitable for the growth of fungi and microorganisms of all kinds. We control the environment into that box using this PCB that we designed and electronic components that regulate temperature and humidity. And now I think Maud will make a tour because she has all the tools we make.
Exactly, because I'm in the studio, so the incubator are just there. So let's just switch from the presentation for the real life, let's say. So I suggest you to put my little box in full, then you can see it better. So this is our incubator. I think you see it here. This is like other version, like just next to it's other version with other sizes, because we are like prototyping a new incubator. And the things like the wood box is made from a parametric software, which is FreeCAD. So you can easily change the measurement and change the sizes. So it's why also we have different sizes. So this wooden box is CNC milled, and it's just assembled with T-bones. So no screw, no screw, no screw, no glue. Then we 3D printed a lock door, and inside you have the laser cutted shelf. Here, basically, wood laser cutted shelf. And inside the box, you have the electronic, which is a fan and heating pad, and a temperature and humidity sensor that are controlled here by, so in the previous version, it was the Arduino, so another version of an Arduino made in FabLab Barcelona, and the PCB that we designed and milled at FabLab Barcelona as well, and a 3D printed case just to put here up. So
that was the first version we made, like the second version actually, but the first one made in a FabLab. Now we are working on the next version that you will be able to see in the following weeks, I hope.
Yeah, so because we want to add a screen, tiny screen, and we want to use a Raspberry Pico instead of the Arduino. So we already like made the new PCB, and the idea is like the Pico comes here, the screen here, you will have the little buttons there, and then we connect the temperature and humidity sensor and the heating pad and the fan. So it's just composed by that. It's everything work with 12 volts and with 1 amp. So those 12 watt, which is not that consuming. So it was also important for us to keep something with low power.
And basically what we would like to demonstrate here, like even though maybe you still don't understand what's an incubator and why we use it, but we'll explain it as soon as possible. But like we would like to explain that everything is made into a Fab Lab using open source software and parametric design as well. Yeah, and that's it.
And we have a question from Alex in the chat, which asks if it's possible to make the box with the laser cutted instead of the CNC. Depends on the size of the box, I would say, because for that size, the laser cutted will be too thin, and then I don't think it will work. But if you make a tiny box that will be smaller, then I guess it will work. The thing is that we also want to make the electronic that you can take apart and put it in any box you have at home, or any dowel or anything, and then you can start to ferment things or to use the incubator without having the CNC box.
Yeah, depending on the material, I would say, like for us, using the CNC was a choice to have that thickness in the wood. Like now it's 12 millimeter thickness for the wooden board. And that was easier for us to make it with the CNC.
Yeah, also we like the fact that you have an object also at home that you can put in the middle of your home, which is an object that you want to see. It's part of your environment. Anyway, let's go back to the presentation. So, okay. So next.
Where are we? Yeah. So, but why are we making an incubator now? Like making it, as you could see, is quite easy. It's not a complicated technique. It's like few components and few Fab Lab techniques to assemble it. But the point is not how to make it, but why are we using it and why are we pushing for it, for its use? So we would like to work directly with hacking and DIY methods for and through the use of bacteria, molds, yeast, and to discover the power of invisible nature and fermentation. We want to move from an extractive economy to a regenerative economy and to be more conscious of our natural environment and its resources. We will explain that a bit more after, but now you already get the point.
And I also just want to add that it's also the one thing I really like also, it's like slowing down, because when you wait for something to ferment, it triggers you feeling of satisfaction because it runs completely differently of the spirit of the modern day. It's really much slower than everything around us. And I think there is at least for us, a real desire to slow down in the midst of such fast paced life in which we are now.
Slowing down, having time to observe, having time to understand what's around us. I think it's very important for us right now. Yeah. and then like we have like possibilities with that incubator, but we decided to focus on fermented food only, at least for now.
Yeah.
And
first, I would say.
Yeah, firstly, because we like to think of fermentation as a process of partnering with microorganisms to enhance our local and seasonal food and to move away from rapid global manufacturing processes.
Yes, so fermentation is not, so fermentation is the transformation of food by microorganisms. So it could be whether with bacteria, yeast, or mold. So simply put, the microbes responsible for fermentation transform more complicated foodstuff into raw material your body needs. And it's also improve your immune system, because our digestive system is mainly composed of bacteria, which is our bacteria flora. And fermented products maintain and promote the richness of this bacterial flora and will stimulate the gut's natural immune system. So we need bacteria and bacteria need us. So it's nice to work with them.
And also like we are not scientists, but we really like it. And
food we learn by doing.
Yeah, exactly. And food can have a complex architecture, enough that we cannot absorb all the nutrients that we are eating. And these bacteria helps us to break down the molecules and to be able to absorb all the nutrients, protein that are in the food.
Vitamins, minerals.
Yeah, we need them and we love them and we are filled with bacteria. But then we also arrived to that statement that, as you know, like the climate now is not in a good shape. That animal agriculture is responsible for up to 91% of Amazon destruction. That livestock covers 45% of the Earth's total land. Sorry, and that we are still currently growing enough food to feed 10 billion people. And so we're like, okay, so if our eating habits are destroying the planet, if we use the land for animals instead of us directly, but still we have enough resources to feed everyone and to be happy on this earth, what could we do? And that's why we decide to push for fermented plant-based protein as an effective solution to reduce greenhouse gas emissions for health and environmental benefits.
Yes.
And, yeah.
And so fermentation is not a new practice, but we want to re-implement it in the contemporary food system, where the post-war industrialization just encourages us to be passive consumer and meet our needs at the supermarket. And we think that going back into traditions and processes like fermentation will contribute to change us as active consumer and take part of the food system.
Yeah, and fermentation will make you healthier, make you feel more connected with food production, with tradition, with communities, and with the living world. That's a quote from us. could be strange, but we really think that that the reappropriation of food using fermentation, everything changed for us as soon as we started fermenting food at our place, getting closer to the production, getting closer to how it's made, how it's good for us or bad for us. And I think it's really needed, as I already said before, like in these strange times, to understand more what we are doing. And then,
but let's speak about something more concrete. So as an example, we use our incubator to make tempeh. I don't know if you had the chance to already taste tempeh or if you know this product. But so it's Indonesian fermented food product originally made of soybeans and a fungus called rhizopus. The taste evokes aromas of mushroom, nut, and yeast.
And yeah, during the fermentation process, the spores of the fungus of the rhizopus develop, and its mycelium grows around the soybeans. We say soybeans, but we can make tempeh with any legumes, but the soy is high in protein. And so this mycelium grows around the soybeans, breaking down their molecules. This process change the properties of the soybeans and make them more digestible for our body, allowing us to absorb all the proteins available and making tempeh as high in protein as meat.
Yes, and the thing is, like, the Indonesian weather is favorable for the growth of rhizopus, but in other locations, like for example in Belgium, in Amsterdam, or in Barcelona when it's not the summer, an incubator may be needed to initiate the fermentation process. But using an incubator is just an example to make tempeh. Using an incubator to make tempeh is just an example. There are many ways to use it, but it's the way we start to use it. So it's the way for us to present our incubator. So
maybe we can make a little detour here to explain why are we making this project. I think it's not in a slide, but I think it's important to explain it. We were living in Amsterdam 2-3 years ago, and there we discovered tempeh, and we turned vegan being there, and we had to discover new types of food and new types of nutritious elements. And there we had like a tiny flat with a tiny boiler room, which was always around 30 degrees because of the heating system. And it was super easy there to ferment stuff, everything in that tiny room. And then when moving from Amsterdam to Barcelona, we had in that room, and in the summer, so we arrived in the winter, and in the winter, the apartments are not insulated correctly, and so it's like cold in the winter and hot in the summer, and not at a constant rate for fermentation. So we had to build that tiny room that we had in Amsterdam, that is like naturally present in Indonesia, let's say. We had to build it to control that environment, to be able to continue producing the food that we like and that we eat almost every day now. And so that's why we are now focusing on tempeh, just because we need it and we eat it and we are able to make it.
I suggest you to continue to to explain how to make tempeh then.
And so how to make it, yeah. So you choose your beans, like we like to make it with soybeans. You can make it with chickpea, with rice, with lupin, with any kind of legumes, with peanuts, like the peanut tempeh is really good also. So you take your beans, soybean, the rhizopus, you will need a bit of vinegar to add acidity into the mixture. You soak the soybeans overnight to make them more easy to cook afterwards. And after that, you can remove the hulls, so that the protection of the soybeans, you remove it so the mushrooms can eat what they need into the beans and grow around them. After that, as I said, you add a bit of vinegar. In Indonesia, you don't need to make it because acidity will come naturally with the temperature that we don't have here. So we add a tiny bit of vinegar to repulse the bad bacteria that we don't want to have. You dry the beans very well after cooking them. You add the spores of the mushrooms, of the mycelium, of the rhizopus. And then you shape the tempeh into molds or zip bag or banana leaves, as it's made traditionally. We use molds that we design in 3D print, as you can see, like the zigzag shape or the rectangle or the stackable ones, like we have different models. So you shape the tempeh to molds and then you put it into the incubator for 24 to 30 hours, depending on life, I would say. Like we don't control everything into fermentation. So 30 hours at 30 degrees. And then the mushrooms grow around the soybeans and form that white and compact block that you can see on the bottom right picture. And that is tempeh, the product of tempeh. And then that one you can cook it as you wish, slicing it, frying it, making a marinade with it. Yeah. Just talking about it, I want to eat some.
Well, so this is what we do with our incubator. So let's go back now with the incubator itself. And why do we want this incubator, this tool, open source? Mm-hmm. Because we want to keep it accessible, repairable, and community-based. Because we advocate open source tools to allow others to understand, modify, and repair what we produce to promote like a bit of resilience and be able to know what you do and understand. So that's the idea.
And just before moving on, I think we have a question from Alex in the chat, which is asking which material did you use for the molds? Because 3D printable filaments could not be compatible with food.
Yes.
We use PETG filaments, which is like the plastic same plastic as we use for the plastic bottles. PETG could be a food grade filament depending on the printer that you use and the brand of the filament that you use.
The PETG material by itself, it's food grade.
Yeah, and then the condition in which you use it could remove or keep that certificate, let's say. But we are currently making an exchange with a Tempeh producer in Amsterdam, and she's teaching us how to modify our molds so that we can use it more safely, and that could be more efficient into the Tempeh production. So now, let's say that it's still the prototyping phase, and we use that filament, even though it's maybe not perfect for food use. We are also exploring silicone, and would like to explore ceramic as well at some point.
I just want to add that, so the molds, because the things with the molds, the material is food grade, the PETG is food grade, but what is not food grade, it's like, because with the 3D printed process, you have little hollows on the mold, and then I have the mold here actually.
Ooh.
And then so there is some bacteria, bad bacteria that can stay here, and it's a bit difficult to clean. So it's why it's not, the 3D print is not food grade at the end. But if you print it with the higher quality, so to avoid that kind of allows, and then you sanitize it each time you use, then for personal use, there is no problem.
And to sanitize it, you can use basic soap or vinegar, which is good, or alcohol. Now we are trying, because we are producing vinegar from kombucha, and now we are testing if it's acid enough to kill all the bacteria. So maybe we could have like a in-house solution also.
Okay.
You're welcome, Alex.
So why do we do open source tools? And because we want. So I maybe.
Yeah, because we would like to switch from this idea like one to many, to switch from that to many to many. I think it's important for us. We deeply believe that what we do has much more meaning and impact when we are not the only ones doing it. That working within a community shows better and faster results, and seems to be a key to resolve emergency problems. We cannot be alone in doing that. We learned from others, we started to teach to others, and we want to continue to learn from external inputs. This by promoting transparency, understanding, resilience, and equity.
And it's why we use digital fabrication techniques to prototype and produce our devices, to allow others to reproduce them in any Fab Lab makerspace around the world.
Yeah, I really like these two slides, like from the Fab Lab network to the mycelium network. So using this digital fabrication and distributed design, but also this decentralized fabrication, to be connected with creatives, innovators, citizens, to participate into the creation of a new model of production and consumption, in which is also like one of the baseline of the Fab Lab network, but in which bits travel globally while atoms stay locally. And that is very important for us, to share our design, share how to make stuff that we make, but without sending wood or plastic across oceans. We don't need to do that. If we have all the resources in any Fab Labs around the world, we can just use this model that we push for and use it for the good cause.
And I think also the things like we learned, we had experiences with Fab Lab, we learned a lot about this new model, and then we want to put it in practice, because we first did the incubator for ourselves, and then because it was mainly made into a Fab Lab, then it's actually we can share it, so we just start to share it, and it's where we are now. So I can actually tell you a bit more about our journey so far. So we start with the Domingo Club, so with the name 5 months ago, and since then we have generated interest, we reach out to communities and received awards and joined cohorts. So it pushed us also to continue to share and to continue to promote this our work, and try to make it be completely involved in it. So we are currently involved in the Food Shift Accelerator Lab. It's funded by the EU, and it aims to transform food system to citizen-driven approach. We are also part of
the Food Shift Accelerator Lab is also called Food Tech 3.0 in Spanish. Yeah, just wanted to add that.
And it's here in Barcelona with the Fab Lab Barcelona.
And so that accelerator program is focused on the local resources. So teaming up with companies around us and projects around us.
And with this program, so it allowed us also to continue to use the Fab Lab and continue to prototype and continue to make incubator. Then we are also involved in the Food System Game Changer Lab, which is more global, and it's in the support of the United Nations Food System Summit. And it aims to support ideas, entrepreneurs, and initiatives that have the potential to transform the world's food system. We are part of the Innovating Protein Cohort, and together we try to make some decision and to present some problems and decision to this summit.
And so that one is more global. So with that one, we are speaking with different people from all continents and trying to resolve. Yeah,
it's also super interesting to see the vision in different continents, because here we have a vision which is more from Europe, and then it's nice to speak with Asian people, African people, American people, and see that we are not facing completely exactly the same problems.
But we can still find a global solution, because like we have all different issues, different depending on where we live, but still facing the same emergency for the planet.
Yeah, sure, but not the same way to do it, I would say.
Yeah, exactly.
The same vision. And also just want to tell you that we have entered competition, and we have won the Distributed Design Awards 2021 with the Project Excellence. So it's really motivates us to continue to work on this project. We also won the Wikifactory Challenge with the 3D printed mold with the prize of functionality, and then we receive a Meku form box, which will help you to continue to design the 3D mold and find way to make it with other materials than 3D printed filament. And we have been selected to be part of the show Design in Age of Crisis in the context of the London Design Biennale. So that's it. But now, what is interesting also, it's how can you join this journey?
Yeah, because it's important for us. Like as we said, we open everything to be able to be a lot of people doing the same thing and trying to use and modify what we do to find new purposes to improve our techniques and to share researches. I think it's very important, and that's why it's mainly why it is open source, right? To be able to invite everyone to contribute to it.
And then we want to encourage you to observe natural system, to play with our tools, to explore mycelium possibilities, and share your researches with us. And because now we using ourselves our incubator to make Tempeh, but we also want to make other experiments. But I think if everybody join this journey, then we will make even more experimentation, and then it will like just scale up the purpose of the incubator.
I think we really would like to see incubator, this open source incubator, into any Wetlab, biolab around the world, in the fab labs, in kitchen lab, as we like to say, also to bring science and research into everyone's place, and to investigate the power of mycelium, to find new biomaterial, to find new techniques, to find new playground, let's say. It's important to have fun while finding a global solution. And I think we reach the end of the presentation.
Yeah.
Thank you. Gracias. Merci. You can find everything, like we try to document everything that we do on domingoclub.com. You can follow us on Instagram. We also have like an RSS feed. If you don't like Instagram, we share, or trying to share everything on GitHub. We are maybe not up to date. Apparently a link is broken. I don't know which one. which is broken? Maybe the maybe the RSS. Well, we will fix them. And yeah, we try to document everything that we do. If it's not documented, you can ask us and we will do it. We have like different things on our to-do list. Someone is asking if we can give an update on the sriracha sauce that we made. We will do it as soon as possible. Maybe this summer if we have time to do it. And yeah, follow us, keep up to
in
date.
touch with us.
Please reach us to modify, to have more information, to participate in the change that you want to see in the world, because we think that everyday habits make the big changes and that the big changes make the everyday habits. So yeah, join us. If you have any question, any interrogation, or if you want to add anything to what we have just said, please do it now. We still have time to discuss and yeah, to take part of this presentation. Thank you, Maudi.
Thank you, Tony. Thank you, everyone.
A pleasure to present this with you.
Yeah.
Thank you, guys.
Thank you. So apparently a link is broken. I can check if it is. But like we, maybe the link to the incubator could be broken. Oh, thank you, Arman. And hello, Arman. Nice to see you here. The incubator, we are still documenting it. Like now it's almost nothing is done there because we are in between the V2 and the V3. And we had the chance to use the FabLab Barcelona all of the months of July. And so we were busy making and designing, and we hadn't time to documenting, which is a pity, but we are working on it. And we hope to bring pictures, videos, source files, and explain how we use the machine to build it. Yeah, I hope this gave you a sense of what we do and maybe bring you the invite to try to ferment food and to discover this invisible nature that we like. And yeah.
Thank you everyone for coming. And
Thank you
hope
for sharing.
Thank you, and hope to see you, to keep in touch through different spaces, different places.
Yeah.
So I think we're gonna end this theoretical session.
We still have one last question.
Yeah.
How do you control humidity? So currently we don't. We are planning to control humidity in the next version. We were about to add this control of humidity, but finally we decided to take a shorter way to the next prototype. But our plan to control humidity is using an atomizer module, which is using ultrasonic sound, ultrasonic waves to break down molecules of water, like the same that we can find into the, how is it called? The essential oil diffuser. So this one that make like a smoke, a cold smoke, which is not vapor, but it's still like this liquid state, but floating into the air. And using this, which is like consume almost no energy to produce these ultrasonic sounds and can spread water into the air. So that's the plan that we don't do now, but I hope that we will do it in the next version. But like controlling humidity is not that important for Tempeh for now. It will be for growing other mushrooms.
Yeah. Cool.
Yeah. But Alex, what kind of mushrooms? Or because now we are looking, we don't have a lot of knowledge on growing mushrooms, and we would like to have more. So if you have ideas or techniques that you want to share, please send us a mail or something to discuss it. It would be a pleasure.
I'm just at the beginning at the moment, but I'm just started some first experiments because I love brewing beer and I always have a lot of edible waste afterwards. So I thought, why not use all this waste and grow some mushrooms on it?
Mm-hmm.
And yeah, but I've just started. Probably I'll try oyster mushrooms, king oyster, maybe shiitake. But as I said, I don't have experience yet. But
Okay.
if I gain some, I'll get in contact with you guys.
Cool.
Thanks for the
Thank
great
you.
workshop.
Thank you.
Thank you.
And yeah, if you want to team up into the experimentation, we can also try to make text together. It would be a pleasure. Okay, so is it time to breakfast then?
Yeah, time to breakfast. Yeah. If no one has another question, then we will just end this session. Yes. Thank you everyone for coming.
Thank you all.
It was a pleasure.
Thank you.
Bye.
You're welcome. Bye.